Okay. Percents of increase or percents of decrease. We're going to find percents of change in quantities, and then we're going to be able to explain the meaning of percent of change. We're going to find the percent of increase or decrease in the quantity, and then we're going to find the percent of error of a quantity. So percent of increase or decrease. What we want to do is we want to be able to compare performance of two individuals who are at two different areas of their careers. For instance, if we were to compare your field goal attempts on the basketball court with Michael Jordan's, automatically we all know that Michael Jordan does better than any seventh grader. However, what we'd be seeing is that if you keep improving your game, your improvement, your percent of increase would be greater than Michael Jordan's, because Michael Jordan would already be up at the top level. And so his increase, his percent of increase is going to be less than yours because you're starting your basketball career, for lack of a better word. And so we would see that you might increase 10% for a while. And then your percent increase will start decreasing as well. But it gives you that idea of like, hey, I'm not Michael Jordan, but I'm improving. And so percent of increase shows us how we can improve things. Another good example would be we as teachers, we each earn a salary. And at the end of the year, we get a percentage of our salary as a raise for staying within the same school district. So, for instance, Mr. Dickinson gets more of a raise than I do monetarily. However, as a percent of our current income, we get the same amount of a raise. So I don't know what it is. Let's say it's 3%. We would both get 3% increase of what we're making now for next year's salary if we stay with the school district. So that way we keep the amount of raise even across the board. So likewise, if companies have to do something to their prices or their salaries, they like to do it as the same decrease of percent across the board, just to keep things quote unquote fair. So to determine if a situation is a percent of increase or a percent of decrease, you must consider the values. And the reason why is if we look, we have two formulas. In one, we have the new amount minus the original amount divided by the original amount. And the other one, we have the original amount minus the new amount divided by the original amount. And the difference here is that we're looking at the numerator, and the numerator needs to be greater than 0. And so, for the new amount to be greater than the original, we're finding an increase. And if the new amount is less than the original, we're finding a decrease. So let's look at this first problem. The table shows the number of hours you spent online last weekend. What's the percent of change in your time spent online from Saturday to Sunday? So we're going from Saturday to Sunday, meaning Saturday's the original and Sunday's the new. So we look. In this case, the new value, 4.5, is greater than the original value. Because of that, we know that this is a percent of increase. So first thing that we decided then was increase or decrease. And we're saying that this is an increase. Then we're going to use our formula. Percent 4.5 minus 2 divided by 2. 4.5 minus 2 is 2.5 over 2. And then 2.5 divided by 2 is 1.25. Now this is a decimal, and we're supposed to have a percent. So we're going to multiply this by 100 to get us 125%. So the time spent online on Sunday is a 125% increase. Now, let me help you understand what this means. This means that, I just wanted to do this. What we want to notice here, this number here is the actual 125% of 2. And so what we're doing is we're adding this 2.5 to the 2 to get the 4.5. So this right here is the actual, this 2.5 is the actual increase, and we're finding out the percent of increase. So how much does this increase by percent versus how much did this increase by hours? So let's look at the next problem. The bar graph shows the softball players' home run totals. What percent of change from 2016 to 2017? So 2016, oh, by the way, this is original. This is new. So right here we have original, and right here we have new. And we have to decide increase or decrease. And so we think this through here, going from 28 down to 20, that's going to be a decrease. So we look. We want to keep our numerator positive, so we're going to go 28 minus 20. And our original value was from 2016, so that's the 28. So now we're going to subtract. 28 minus 20 is 8. And we're going to divide 8 by 28. Oops. 8 divided by 28. Doesn't say what to round it to, so I'm going to round it to the third decimal place because that'll give me a nice clean percentage. This 5 will go up to a 6 because that 7 is greater than or equal to 5. And once we have this decimal, we're going to take this decimal and multiply it by 100, which gives us 28.6%. So 2017's home runs are a 28.6% decrease from 2016. Now, I'd like to point out again, right here, this 8, that is 28.6% of 28. And that's what we're subtracting from 28 to get down to 20. So, percent of error is the percent of error that is estimated, that an estimated amount differs from the actual amount. This is the idea of if we produce things, we have target values. Not every phone is perfectly shaped. Not every nut and bolt are perfectly shaped. they fall within a tolerance, and there's a percent of error that we allow or we disallow. If your phone is probably down to like the nearest millimeter, because it's got to fit in these standard phone cases, and the phone cases then have to be with down to the nearest millimeter to fit into their phone cases, to fit the phone. Sorry, and so we've got to keep everything within a certain amount of tolerance to be able to produce things on a mass scale. And so percent error is the amount of error divided by the actual amount. So the amount of error we'll find by subtraction. This is still the same idea. The reason why we're teaching this now with percent of increase and decrease is that really we're doing subtraction. It's just that we're not going to go new minus original. We're going to say, hey, we need to find the difference between these two values, but we also have to keep that difference positive. So a lot of times in the future, you'll do absolute value. You'll be like percent of error is you'll have a target value minus the actual value, and you'll divide it by the target. And this will be your formula, but this we find a little too complicated for 7th grade. So, our example, you fill bags with about 16 ounces of homemade dog treats. The acceptable percent error when filling a bag is 5%. Tell whether each bag is acceptable. So here's our target right here. We want to get to 16 ounces, but our actual value is 15 ounces. So we're going to find the percent error. So the first thing we have to do is figure out, okay, if I subtract 16 minus 15, will that be positive? Yes. So 16 minus 15 divided by our target value of 16. So we have 1/16. So we divide 1 divided by 16. That gives us 0.625. If we take 0.625, multiply that by 100, we get 6.25%. This is unacceptable. Let's look at the other one. The other one we have as 16.5 for the actual. So we have to put the 16.5 first, because that way we get a positive numerator. 16.5 minus 16 gives us 0.5. 0.5 divided by 16 is 0.3125. So if we take 0.3125, we multiply that by 100, we get 3.125%. This is acceptable because this is less than 5%. Last two problems here are to help you understand how we can use a percent of increase or decrease once we know it. Lori decides to study 20% more than she currently does for her history test. This means she will study for 24 minutes. How many minutes did she study for the last test? Okay, so she's studying 20% more than she currently does. So her current studying is 100%. So she's adding 20% to that to get 120%. So, and we know that 120% of 24 is prior. Oh, sorry, I did that the wrong way. 120% of former study time is 24. So we don't know this, which is our W. And we know this is our P for percent, and this is our A. I'm going to do this one by proportion because I feel like it. So 24 over W equals 120 over 100. We cross multiply. That gives us 2400 equals 120 W divided by 120. So that should give us cross. That's going to give us 20 minutes. So we know that last time she studied for 20 minutes. So what that also means is that if you go 24 minus 20, we know that the 4 minutes is the 20% increase. So this next one, Tim improves his 100-meter relay time by 8%. His new time is 11.04 seconds. When you improve a relay time, that means you're decreasing. And so if we look at this then, we know that we started off at 100%, but we're decreasing that by 8%. So that's 92%. So then we know that 92% of the original is 11.04. So knowing this, I'm going to use the equation this time, PWA. So I can go 11.04 equals 92% is 0.92 when written as a decimal, W. We're going to divide both sides by 0.92. So we have 11.04 divided by 0.92, which gives us 12. So Tim's last race, he ran the 100-meter relay in his leg of the 100-meter relay in 12 seconds. So there we go. The rest of this is practice work, and hopefully you see the difference between the types of problems and you can successfully complete them yourselves.